Jai Hind students. Today we are going to solve worksheet of current electricity. In this, we are solving questions MCQ types based on your current CBSE pattern. So, question number 1 says that dimension of a block are 1 centimeter into 1 centimeter into 100 centimeter. If specific resistance of its material is 3 into 10 raised to the power 7 ohm, then the resistance between the opposite rectangular face will be. Opposite rectangular face means these are the dimension 1 centimeter by 1 centimeter to the 100 centimeter. So this face and the opposite face, which I am going to draw with a red pen, this one. What would be the specific resistance? So answer of this question is option number B, that is 3 into 10 raised to the power minus 7, because we know that R is equals to rho L by A. Now the resistance is same, length is same, area of cross section is same, so the specific resistance will also remains the same. Or if you can't understand by this way, you can also assume that specific resistance is nothing but the resistance per unit area. Will that be okay? So in order to, in that way also, the resistance will be same, 3 into 10 raised to the power minus 7. If you see the options clearly, here it is written that 10 raised to the power minus 5, 10 raised to the power minus 3, minus 7 and minus 9. So this will not change as per the dimensions. Are you getting my point or not? Okay, coming to question number 2. In a Wheatstone bridge, all the four arms are having an equal resistance R. So what do you mean by Wheatstone bridge? If you just saw this question, suddenly your mind should strike to this figure, because this is the ideal figure for the Wheatstone bridge. Here is P, Q, R and S. These are the standard, and what I know is P by Q is equals to R by S. Under which condition? Under the null point condition, because at null point there is also a resistance which gets opened. Got the point? So in a Wheatstone bridge, all the four arms have equal resistance R. If the resistance of the galvanometer arm is also R, then equivalent resistance of the combination will be. Now the equivalent resistance means आपके पास एक resistance ये रहा और दूसरा resistance इसी के साथ series में ये रहा. So there is a resistance of total 2R. Why? Because they both are in series. Now the another resistance in this way and the other is this way. Again it is R and R. Okay. So again 2R. Now the question becomes like this way. There is a 2 resistance whose value is 2R, and there is another resistance whose value is 2R. For a parallel combination, multiplication of both the terms, 2R means 2R upon addition of both the terms, 2R plus 2R. This is the generalized formula. So either way we will get 4R square upon 4R. 4 gets 4 cancel, R square cancels the single power. Finally, we are reached with only R. So in this way, correct answer will be A. Are you getting point? Coming to question number 3, a potentiometer is an accurate and versatile device to make electrical measurement of EMF because the method involves. Now in these type of questions, you should always remember the principle. On what principle does the instrument works? Are you getting? So when you read the options, suppose I read the first option as potential gradient because its methods involve potential gradient. Okay, it comes to my mind that yes, potential gradient could be the correct option. Why? Because my potential is changing depending upon the length. As I increases the length, potential drop becomes increasing in nature, and the potential is length is decreasing, so the potential is also decreasing. Third option is a combination of cell, galvanometer, and resistance. This could not be the answer. By seeing the option also, if you know little bit about the potentiometer, not because of the combination of cell, galvanometer, and resistance, it measures the EMF. If this could happen, then anything could be a potentiometer device. Option number D is cell. This could not be the correct answer. So we are left with option number A and B. Option number B says to you that a condition of no current flows through the galvanometer. Yes, this could be a more precise answer. So in my point of view, this will be the answer. Answer number B. That a combination of no current flow through the galvanometer. In that case, we are able to measure the EMF of any cell. Are you getting my point? Coming to question number 4. Question says that consider a current carrying wire, current I, in the shape of a circle. In the shape of a circle. Note that as the current progresses along the wire, the direction of J, what does J depends? What does J denotes? That is current density. Changes in an exact manner while the current I remains unaffected. The agent that is essentially responsible for is. Now, this question comes from the NCRT exemplars. So, when you are going for a board examination, it is always advisable to you that before going to examination, just solve NCRT exemplar problem, because their language is so twisted. They are so twisted that when you solve them, you will get a crystal clear concept of the topics. Okay, as the question says to me, let's revise it again. Consider a current carrying wire I in the shape of a circle. There is a wire in the shape of a circle. So there is a wire in which current I flows, and we have to note that current progresses along the wire. That means if we are moving in this direction, my current is also increasing, and the current density changes in exact manner while the current I remains unaffected. Now, two things are changing. One thing is changing, that is current density, while the other thing, current I, remains unaffected. But question also says to me that when I move progressively in the wire, my current is increasing. The agent that is responsible for is. So as per the question, if I read the answers, that is source of EMF, this could not be the answer. The charges just behind a given segment of wire which pushes them just the right way to the by repulsion. The charges ahead, question option number D. And option number B says to me that electric field produced by the charge accumulated on the surface of the wire. Yes, this could be the right answer. Why? Because the electric field produced by the charges, this will always be stored on the surface of the wire. This is the charge density. Charge density means J is equals to I by A. Current flown through the unit area is known as charge density. If the area becomes 1 meter square and the current is of 1 ampere, then the density will be said to be 1 by 1. This is 1 ampere per meter square. This is the current density, and this is stored at the surface of the wire. So in this way, you are supposed to solve the MCQ sheets I have provided to you. If you have any facing any problem, then contact to me. It's a very limited time, so put your 100% in preparing for term 1 examination. All the best. Good luck to you.